So here we're going to work through the IGCSE foundation paper, but it's the R paper. It's the paper that would have been taken by overseas candidates from the 21st of May 2019. So question 1, write down a number in each box so that each calculation is correct. So if we're adding two numbers together to get 486, the easiest way to work this out is just to work out 486 take away 357. That will tell you what you need to add to get to it. So 486 take away 357 is 129. All right, so 129 add 357 is 486. How did we work that out? We did 486 take away 357. Similarly with number 2, we're trying to work out what you'd multiply 23 by to get 184. So undoing this, working backwards, we need to do 1840 divided by 23. What's the opposite of multiplying? It's dividing, whereas with part 1, what's the opposite of adding? It's subtracting. So 1840 divided by 23 is 80. So B part 1, show how the cards can be arranged to make the smallest number using all 4 cards. So to get its smallest overall, you want to have the smallest number first, then the second smallest, then the third smallest, and so on. So that's going to be 2, 4, 5, 7. Now, to make it an even number, we need to have either a 2 on the end or a 4 on the end. So there's many answers you could do here. So I'm going to go for one which has got the 2 on the end. So I just need to have the 7, 4, 5 in any order beforehand. So just so you're clear, there are numerous correct answers for B part 2. Just make sure it finishes with either a 2 or a 4. Question 2. In which of these 5 countries are 7 million hectares of land used to grow rice? So 7 million hectares. So 7 would be about here. So that's going to be Vietnam. Part B, how many millions of hectares of land are used to grow rice in China? Here's the China bar. Read off how many hectares. That's 30 million. C, Thailand, 10 million hectares are grown. Okay, so Thailand's got to go up. So 10. And more land is used to grow rice in India than in Cambodia. How much more? Well, India's up here. So as long as you've got something around 43, there was leeway in the mark scheme because it's not that obvious. Just make sure you've got something between 40 and 45. 43 looks about right. And then then Cambodia is here. So obviously between 0 and 5, I'm going to say 3. But again, I think anything between 1 and 5 was between 0 and 5 was allowed. So the difference between 43 and 3, 43 take away 3 is 40. Question 3. So part A. Write 0.72 as a fraction in its simplest form. So 0.72 is 72 out of 100. So simplify that down. If we halve that, we get 36 over 50. Halve that, we get 18 over 25. I don't think we can simplify that anymore. Right, 3/4 is a percentage. Well, you could just pop that into your calculator. 3 divided by 4 times 100 if you just don't know it. But 3/4 is 75%. Right, work out 65% of 720. Now 65% is 65 out of 100, which if you work that out is 0.65. You take that, multiply that by 720 to work out what 65% of 720 is. So 0.65 times 720 equals 468. Now I think for part D, it's easier just to start off by turning them all into decimals. So that one's already done for you. 9 divided by 20 gives you 0.45. 40.5%, so divide that by 100 you get 0.405. 4 divided by 9, we'll just work it out. 4 divided by 9 equals 0.4 recurring. That's 0.44. And the 4 is going on forever. And 0.427. Now, once you've got them all being decimals, it's easy enough just to work your way through. So that's the smallest one, isn't it? 0.40. Nothing else is 0.40. So that's that one done. Then 0.42 is that one. Then 43. Then 44. And then 45. So now that I've got the order, make sure you just write the answers down. So my smallest one is the 40.5%. My second smallest is 0.427. Third smallest, 0.43. Fourth smallest, 4/9. And biggest is 9/20. Question 4. On the grid, draw a rectangle with a perimeter of 14. So it's just got to be 14 all the way around. So how about 4, then a 3? That's taken up 7. And then another 4, then a 3. So that is one example, okay? Because 3 add 3, add 4, add 4 equals 14. Now, a right-angled triangle with an area of 12. So remember, a triangle takes up half the space of a rectangle. So what rectangle would we have? What would be the area of a rectangle if the area of the triangle was going to be 12? Well, the area of the rectangle would have to be 24. Now, given an example of a rectangle, the sides of a rectangle where base times height equals 24, well, that could be a 6 by 4. 6 fours are 24. So 1, 2, 3, 4, 5, 6. If I go along 6 and up 4, and then put in my diagonal, that's going to have an area of 12. Okay, because half times 6 times 4 equals 12. So that is one of many examples that would suffice for 4 part B. Question 5. Work out the difference between the temperature in Vancouver, which is 6, and Edmonton, which is -8. So picture a number line, okay, where we're going all the way from -8 up to 6. What's the difference there? Well, it's 8 to get up to 0, then another 6. 8 and 6 is 14. If you like, you could have gone 6 minus -8, which would have been 6 plus 8, which is 14. Now for part B, the temperature in Yellowknife is lower than the temperature in Ottawa. How much lower? Well, Yellowknife is -23. Ottawa is -5. So again, just picture a number line. We've got -5 here, -23 here. The difference between -23 and -5 is 18. Always put a difference down as a positive number, okay? A difference is a positive number. Right, the temperature in Winnipeg was 8 degrees greater than Quebec. Well, Quebec is -20, and then we've got to add on 8 to that. So picture a number line where you're on -20. When we then move 8 to the right, where do we end up? We end up at -12. Question 6. So, write down the word for the box that describes the line AB. Okay, so a line that just skims a circle, so it just touches the circle at one point, is called a tangent. So tangent for part A. Part B, on the diagram, draw a radius of the circle. The radius is the length from the centre to the outside, so that would be the radius of the circle. And part C, work out the angle marked X. Well, angles about a point. Angles in a circle all the way around add up to 360. So we need to do 360, take away 130, which is going to be 230 degrees. Question 7. So Bella buys 4 packets of sandwiches at £2.40 each. So that's 4 lots of £2.40. And 1 bottle of water at £1.20. So let's see how much that adds up to. So 4 lots of £2.40. £2.40 times 4 is £9.60. 1 loss of 120 is 120. So that's £10.80. Now, she paid with a £20 note and got £5.75 change. So how much does she actually spend? 20 take away £5.75. 20 take away £5.75 is £14.25. So she spent £14.25 in total. £10.80 was on the sandwiches and the water, the rest was on the crisps. So how much was spent on the crisps is going to be the £14.25 take away the £10.80. £14.25 take away £10.80. That's what was spent on the 3 packets of crisps. That's £3.45. So work out the price of each packet of crisps. Well, it's £3.45 for the 3 packets of crisps. So if we divide that by 3, we get £1.15 each. Question 8. So A plus A plus A plus A is 4A. 3C times 5C. Well, that's 3 times 5 times C times C. 3 5s are 15. C times C is C squared. Now, for part C, be careful. Make sure you incorporate the sign. So it's 3E added together with 5E, which is 8E. And then for the G's, plus 7G take away 4G. What's 7G take away 4G is 3G. That's plus 3G. Part 4. What number, when you take away 9, gives you 14? Well, I can just see that's 23. But if you couldn't see that by sight, just add 9 to both sides. We get x equaling 23. Now, factorising, that's when we put the brackets in and take out the highest common factor. What's the biggest number that goes into 5 and 15? It's 5. It's the highest common factor. Open bracket. 5 times what would give us 5y? That is y. Get the sign right, it's a plus. 5 times what would give us 15? That's 3. And you can check the answer. 5y plus 15. Now, to make y the subject, so we have to rearrange it so we're just left y equaling something. So 3y, leave that alone for now. Leave the 3 for now. Always leave the component next to the y to last. So the first thing to do is to undo this minusing w. What's the opposite of minusing w? It's adding w. So we're going to add w to both sides. So h plus w equals 3y. How do we undo a timesing by 3? We're going to divide both sides by 3. So y is going to equal. Now, to make it clear that all of the h plus w is divided by 3, turn it into a fraction. So it's h plus w all over 3. Question 9. So we've got 11 counters in a bag. Find the probability that the counter will be orange. So when it's probabilities, always aim to do it in a fraction if you can. So oranges, we've got 2 orange out of a total of 11 counters. So that's going to be 2 out of 11. Right, not white. So we've got 6 white. So we've got 5 that aren't white. So that's going to be 5 out of 11. Okay, part 3. Find the probability the counter would be green. Well, that's impossible. There aren't green. Now, don't put nothing out of 11. Please just put 0. Always put 0 when something's impossible. Now, for part B, we've presently got 12 cars. We're going to add some extra red ones, and once we've added these extra red ones, the chances of getting a yellow car is 1 out of 6. So the chances of a yellow is 1 out of 6. Now, we've presently got 5 yellows. So to maintain the probability of 1 out of 6, that's the same as 5 out of what? Well, the equivalent fraction is what we get when we multiply by 5. So 6 fives are 30. So the probability of a yellow, which is 1, becomes 1 out of 6, and given there are 5 yellows, means that it must be 5 out of a total number of toy cars of 30. Now, there are presently 12 toy cars. We need there to be 30 in total. So how many reds are we going to add? It's going to be 30 take away 12, which is 18 red cars. Question 10, part A. Work out the output when the input is 8. So the input is 8. We're then going to multiply that by 7. Well, 8 times 7 is 56. And then finally we take away 9 rather. 56 take away 9, and that equals 47. Now for part B, we're doing the opposite. We're told that the output is 82. The output is 82. So we do the opposite. First of all, we add 9. So 82 add 9 is 91. And then secondly, we divide by 7, which is the opposite of multiplying by 7. 91 divided by 7 is 13. Okay, looking at that the other way, if you had an input of 13, you multiplied it by 7, you took away 9, you would get 82. Now for part C, we're told that the input is y. So we're taking our input, which is y, we're multiplying it by 7, and then we are subtracting 9. Now y times 7 is 7y, and then secondly, we take away 9. Question 11. Now, it may well be that you've been shown how to use the table function on your calculator. So if you know how to do that, I would recommend you use that. If not, I'll sort of show you the old school way. So to plot a graph, and this is going to be a straight line graph, okay, where you've just got y's and x's and numbers, it's always going to be a straight line. So you're going to need to just generate some coordinates to plot the lines. So we've got our own x values. We set up our own x values. And for each x value, we then go and work out the y value using the equation of the line. So given that we've got to go all the way from x being minus 1 all the way up to 5, you might as well just do those two coordinates and make those the two endpoints of your line. So when x is minus 1, y equals 2 lots of minus 1, and then we take away 3 from that. Now 2 lots of minus 1 is minus 2. Minus 2 take away another 3 is minus 5. So that coordinate that we plot is minus 1, minus 5. So 1 to the left and 5 down. And that's the end point of the line. Now what I suggest you do, just so you don't run the risk of messing up the negatives if you're doing this in your head, if you incorporate the brackets, you can literally just put 2 open bracket minus 1 close bracket minus 3 equals into your calculator, and it will confirm that the answer is minus 5. Now secondly, when x is 5, y is going to equal 2 lots of 5, and then we take away 3. Again, I would suggest just to double check, put that into your calculator to double check your answer, but 2 5s are 10, 10 take away 3 is 7. So our second coordinate is 5, 7. Okay, and then get your ruler out and draw a straight line between those 2 points. Question 12. So we've got 75 marbles, a fifth of them are in bag A. So the bag A marbles is a fifth times 75. Pop that into your calculator. You can either use the fraction button and do a fifth, or we could do 75 divided by 5. and we get 15. So 15 of the marbles are in bag A. So bag B and C combined is going to be 75 take away 15, which is 60. So we're told there are 4 more marbles in bag B than in bag C. Now you could do this by algebra, but I think it's almost easier just to do this by trial and error. So if we've got bag B and C, let's just start off with them having 30 each. Okay, now we need that, and that's obviously the 60. We need there to be 4 more marbles in bag B. So if we go 2 up for bag B and 2 down for bag C, that's creating a difference of 4. Okay, so they still add up to 60, but we've now got 4 more bags in bag B. So our answers are going to be bag A has got 15, bag B has got 32, and bag C has got 28. Question 13. I think at the end of the day, if you've done a few of these, you just know how to go straight to answer. But I'm just going to try and explain the maths behind it a little bit, okay? Potatoes cost $2 per kilogram, and Alfred buys P kilograms of potatoes. Now, they're $2 per kilogram. So let's just think about it. If he bought 1 kilogram, it would cost him $2. If he bought 10 kilograms, because it's $2 per kilogram, it would cost him $20. So how do we get from kilograms to dollars? We just times by 2. So if Alfred buys P kilograms of potatoes, timesing that by 2, that's P times 2, or in other words, 2P. So that's the amount of potatoes he buys in blue there. Now moving over to carrots. Okay, we're told they're $3 per kilogram. So if he buys 1 kilogram, that costs $3. If he buys 10 kilograms, that would be $30. How do I get from kilograms to dollars? I times by 3. Sorry, I times by 3. Now he buys C kilograms of carrots, so we need to times that by 3. C times 3 is 3C. So the potatoes he buys is 2p, that's how much it costs. How much does it cost him to buy the carrots? It's 3c. Now we're told the total cost is $t. So the total cost T is going to be the total cost of the potatoes, which is 2p, plus the total cost of the carrots, which is going to be 3c. And that's our final answer. We've got a formula for T in terms of P and C. Question 14, part A. On the grid, translate shape P by the vector minus 5, 2. Now, translate means shift. So you're just shifting the shape left, right, up or down. It's still going to be that L shape, or sort of backwards L shape. Now, how does the vector work? It works a bit like coordinates. The first number, the top number, is the left-right number. So here we're going to be moving 5 to the left because it's negative. And the bottom number is the up or down number. And because it's positive, that's going to be upwards. So what I suggest you do, take any point you like. So I'm going to take the bottom left-hand corner point and shift that 5 to the left. 1, 2, 3, 4, 5. And 2 up. 1, 2. Now that becomes the new bottom left-hand corner. So I can just draw my shape in from there. I would suggest you use a ruler. I'm not. And that is, again, that is got moving the bottom left-hand corner. Where people go wrong here, they start off using, say, the bottom left-hand corner, and they move that 5 to the left and 2 up, but then they go and make that the bottom right-hand corner or something. So just be consistent with your points. Now, for part B, fully describe the single transformation that maps P onto T. Now, note it's got 3 marks, so you're going to have to make 3 points. So I can see this shape is just rotating around. So this is a rotation. That's my first point. Now my second 2 points, I would really confirm this with tracing paper. Okay, I would put tracing paper over the 2 shapes. You're always given tracing paper in the exam. I would draw around the P shape, I would do an arrow pointing upwards on the tracing paper, and then I would experiment. Now I can just see from experience that my center of rotation is going to be the origin. So I would put my pencil point on the tracing paper and hold it at the origin, and just pivoting there, I would then move the tracing paper around, and I would see that that original black shape ends up over here with the arrow pointing to the right, showing me that it's a 90-degree clockwise rotation. So my final answer would be rotation, 1 mark, by 90 degrees clockwise, 2nd mark, but then you've got to say what the center of rotation is. So about the point 0, 0, or you could say center of rotation at the origin, okay? But just make it clear what your center of rotation is. Question 15. Now, I think this is the first quite tricky question, okay? So we're not being asked to work out the volume of the cylinder. We're being told we're pouring some water into it, and what will be the depth of this water. So imagine you pour some water into it and it goes up to there. We're being asked to work out this depth here. So first thing we need to know, how much water have we got that we're pouring into it? Well, we've got 1.5 litres, and you just need to learn that there are 1,000 centimetres cubed in 1 litre. So 1.5 times 1,000 means we've got 1,500 centimetres cubed of water. So make sure you learn that. 1 litre is 1,000 centimetres cubed. So, how do you work out the volume of a cylinder? Well, it's going to be the area of the cross-section, so the area of the circle, multiplied by the depth. So we're going to have to work backwards here. So the area of the circle is pi r squared. So that's going to be pi times 8.2 squared. Popping that into my calculator. So pi times 8.2 squared, I get 1681 over 25 pi. Now I could press the SD button and turn that into a decimal. In fact, I think I will on this occasion. So that gives me 211.24069. So that is the area of the circle, the area of the cross-section. Now, to work out the volume, you take this area of the cross-section, you multiply it by the depth of the water, and this gives you the volume, which is 1,500. So rearranging this, the depth of our water is going to be 1,500 divided by 211.24069. Okay, just check you're okay with that. We've got 211.24069 times d equals 1,500. How do we undo this multiplying by the 211? We divide by the 211. So I've still got that 211 in my calculator, so I'm going to put 1,500 divided by answer to bring it back exactly, and that gives me a depth of 7.1009 ... So to 1 decimal place, that's going to be 7.1 centimetres. Question 16. So each interior angle of a regular polygon is 162. Work out the number of sides. Okay. Now, we know 2 things about interior and exterior angles of regular shapes. The exterior angles always add up to 360. And interior plus exterior equals 180. So if I know that the interior of 1 is 162, the exterior angle is going to be 180 take away 162, which is 18 degrees. Now, the exterior angles always add up to 360. Now, if each of them is 18, how many of them must there be? So we're going to do 360 divided by 18, and that tells us there are 20 exterior angles, so there are 20 sides. Question 17, part 1. List the members of A intersection B. Now that means the numbers that are in A or B or both. Now I think to really help us gather our thoughts on this, I think a Venn diagram might be quite useful. Okay, so there's my universe. My universe is the numbers 11 up to 20. A is going to be all the numbers that are even, and B is going to be all the numbers that are multiples of 3. Just but from our universe, from our 11 onwards. Now 11 is neither even nor a multiple of 3. 12 is both. It's even and a multiple of 3, so that goes in the middle. 13 is neither even nor a multiple of 3, put it on the outside. 14 is even. 15 is a multiple of 3, but not even, so that just goes in B. 16 is even, but not a multiple of 3. 17 is neither. 18 is both. It's even and a multiple of 3. 19 is neither. And 20 is just even. So I've placed all of the numbers in my universe into either A or B, or A and B, or neither. So back to part 1. List the members that are A intersection B. That means that they're in A and they're in B. Well, that's where the two rugby balls cross. That's the 12 and the 18. Now, part B, A union B, means you're either in A, or you're in B, or you're in both. So that's all of these numbers in here. Now I'm just going to help the marker by putting those in alphabetical order. So 12, 14, 15, 16, 18, and 20. Now for part 3, A apostrophe, that A dash, that means the complement of A. That means all the numbers that are not in A. So the numbers that are in A are anywhere in the A rugby ball, be it crosses, whether or not it crosses with B. Okay, that is all the numbers that are in A. So that all the numbers that are not in A is everything else. Now it could be in B, it could be in neither, but it's not in A. So putting these in alphabet and numerical order, we've got 11, 13, 15, 17, and 19. Question 18. Well, parts A and B are quite straightforward. C not quite so straightforward. So find the highest common factor of 21 and 35. Now you could go and do product to prime factors, number trees for both of these, but I think when the numbers are small, it's almost easier just to think about all the factors of both and then see which one's highest. So all the factors of 21, all the numbers that times by another number give you 21. So 1 times 21 and 3 times 7. Those are the only factors of 21. Factors of 35. So 1 times 35, 5 times 7. I think that's it, isn't it? It's not divisible by 3. I think that's it. So the highest common factor, so the common factors, which numbers are on both lists, are the 1s and the 7s. So the highest common factor is 7. Now for 720, product of prime factors is when you do the number tree. So take your 720 and just break it down. Any two whole numbers that multiply to give you 720, I'm going to do 72 and 10. 72 breaks down to being 9 times 8, for example, and 10 is 2 times 5. Now 2 times 5, 2 and 5 are prime numbers, so we circle those. Our work is done. 9 is 3 times 3, prime numbers. 8 is 2 times 4, of which 2 is prime, and the 4 is 2 times 2. So product of prime factors, I just now go and list all of these numbers that have been circled in numerical order, but more importantly with the time sign between them all. So I've got 2 times 2 times 2 times 2 times 3 times 3 times 5. Now, part C is trickier. When you've got a square number, it's always something times itself. All right, so 3 times 3 is 9. 9 is a square number. 25 is a square number because it's 5 times 5. So imagine we're splitting the 720 down, and we've already done the splitting over here. We've got a 2 times 2 times 2 times 2 times 3 times 3 times 5. So if we're breaking that down into being a square number, it's got to be something times itself. So imagine on the left here I've got the something, and on the right I've got times itself. So if I put a 2 and a 2 here, that will be square, because 2 times 2 is 4. Okay, if I put another couple of 2's there and split them equally, that overall number will be a square number, because I've got something times itself. Similarly, because I've got an even number of 3's, I can go and spread that equally. So what the 3, this first 3 is in the something, and the second 3 is in it times itself. So I don't even need to work out what I've presently got. But when I go and multiply 2 times 2 times 2 times 2 times 3 times 3, it will give me a square number because I've got something times itself. Now, what does that leave me with? Well, that just leaves me with a 5. So find the smallest whole number that 720 can be multiplied by to give a square number. Well, if I want a square number and I've got this 5 here, in order for it to be times itself, I need another 5. Right? I'm missing a 5. So the smallest whole number that 720 can be multiplied by to give a square number is 5. In short, go and look at your product of prime factors. And if you don't have an even number of them, so I've got an even number of 2's, so that's fine. I've got an even number of 3's, but I've only got one 5. So I need another 5 in order that overall I get a square number. Question 19. Now, with any of these percentage increase or decreases, I think it's best to use a percentage multiplier. So let me just remind you about that first of all. If something was going up by 5%, the multiplier would be 1.05. In this case, it's going up by 8%, so a multiplier is going to be 1.08. Okay, the 1 represents the sort of the starting price, and the 8 in the hundredths column represents the 8% increase. Now, because we are going from the price of the dessert before the increase to afterwards, okay, so if you think about 3 columns, we have a before column, the change column, the increase or decrease, and the after column. Because for part A, we're going from before to after, we're going in that direction, you multiply by the percentage multiplier. Okay, so for 19 part A, we'll take off $4.25 and we'll multiply that by the multiplier of 1.08. So 4.25 multiplied by 1.08 equals $4.59. Now for part B, okay, we're still talking about an 8% increase, but we're told that the price of the lasagna after the increase, and we've got to work out the price of the lasagna beforehand. So we're now going from after to before. We're going in that direction, so we now divide by 1.08. So we take our $9.45 and we divide by 1.08. So 9.45 divided by 1.08, and that gives us $8.75. Question 20. So we've got to calculate the area of the triangle. Now the area of a triangle is the base times the height divided by 2, or half times base times height. Either way, it's the same thing. Okay. Now the height that you need is the height straight up. It's the perpendicular height. So that's the 6 on this occasion. Okay. So we know that's going to be 6, and then we're going to divide by 2 at the end. So the issue is, how do we work out the length of the base, which is the length from B to C? Now what you need to do here is to spot that we've got a right angled triangle from A to B to the center. Now, if we can work out the length of that, let's call that point D. If we can work out the length from B to D, we can then double that to get the length from D to C, because that perpendicular line is halfway between B and D. Now, what maths do we use on a triangle, a right-angled triangle, where it's side, side, find another side? Well, that's Pythagoras. And because we're finding the side of one of the shorter sides, it's going to be a taking away Pythagoras. So your first line of workings for the Pythagoras needs to be that BD squared equals 7.5 squared take away 6 squared. Remember, that's how Pythagoras works. If you square both the shorter sides and add them together, that gives you the square of the hypotenuse, the longest side. So popping that into your calculator, okay, 7.5 squared take away 6 squared. 7.5 squared take away 6 squared, we get 20.25. Now, that is what BD squared is, but we want BD, not BD squared. How do you undo a squaring? You square root. So BD is going to be the square root of 20.25. So I've already got 20.25 in my calculator, so I'm going to go square root answer, and I get 4.5, 9/2. So if B to D is 4.5, then B to C is going to be double this. It's going to be 2 lots of 4.5, which is 9. So going back to my area of a triangle, it was the base times the height divided by 2. So the base, the length from B to C is 9. 9 times 6 divided by 2, or if you like, half 9 times 6, which is 27. So our final answer is 27 centimeters squared. Question 21. So we've got 10 people in a lift. Their mean weight is 79.2. So the total weight of the 10 people, is going to be 10 times 79.2, which is 792. So let's just think about that for a minute. If we were working out the mean, we would do the total, 792, divided by the number of people, 10, to get 79.2. So just working it the other way, 10 lots of 79.2 gives you the total of 792. Now, similarly, the total weight of the 3 people who got out, the mean weight, of the 3 people who got out was 68. So to work out the total weight of the 3 people who got out, you're going to do 3 lots of 68. So 3 times 68, which is 204. So the total weight of the 10 people was 792. The total weight of the 3 people was 204. So once they've got out, the weight of the 7 people remaining is going to be the total weight of the 10 people, take away the total weight of the 3 people. So that's going to be 792, take away the 204, which is 588. So that's the total weight of the 7 people. So to work out their mean weight, take the total weight of the 7 people and divide that by 7, giving us an answer of 84 kilograms. Question 22. So when we're dividing, the index law says that we subtract the powers. 9 take away 3 is 6. So that's t to the power of 6. Similarly for part B, when you're multiplying, you add the powers. 5 add 7 is 12. Now for part C, every component inside the bracket has to be cubed. So we've got 5 being cubed. We've got x being cubed. And we've got y squared being cubed. Now 5 cubed means 5 times 5 times 5. Just do that on your calculator, you get 125. X cubed just means x times x times x. That is x cubed. And y squared all cubed, when you've got a power inside the bracket and outside the bracket, you multiply them together. 2 3s are 6. So that's going to be y to the power of 6. Question 23. So, 22 meters per second. 22 meters in 1 second. So, to change that into minutes, because there are 60 seconds in a minute, we're going to times that by 60. So, 22 times 60 is 1320. So, we're going to go 1320 meters, in 60 seconds, which of course is 1 minute. Now, how do we go from minutes to hours? How many minutes in an hour? There are 60. So how do we go from 1 minute to 60 minutes? We're going to times by 60 again. So 1320 times 60 is 79200. 79200 meters, sorry, I said it again. Meters is what we would do in 60 minutes, which is of course 1 hour. So we've presently got the number of meters we would do in 1 hour, but we want the number of kilometers we would do in 1 hour. So how do we turn meters into kilometers? We need to divide the meters by 1,000. So 79200 divided by 1,000 gives us 79.2 kilometers, which is the same as 79,200 meters, which took 1 hour. So what is our speed in kilometers per hour? We do 79.2 kilometers in 1 hour. So 79.2 is our final answer. Question 24. So let's go and have a think about things now. Okay, we've got Tom to Clemmy, and we're told their actual age is 15 to X. Now, 3 years ago, what would their ages have been? Well, Tom is going to be 12, and Clemmy is going to be 3 less than X, so X minus 3. Now, what do we know about 3 years ago? We know that the ratio of Tom to Clemmy was 2 to 7. The ratio was 2 to 7. So let's go and compare the ratio 3 years ago with what actually was happening 3 years ago. Okay, so 3 years ago, Tom's age is to go from 2 to 12, we're multiplying by 6. So similarly over here, we've got to multiply by 6 for Clemmy. So multiplying by 6, 7 times 6 is 42. So 42 is going to equal X minus 3. So adding 3 to both sides, we get X being 45 years old. That's difficult, I think. Okay, question 5. So we're told that the greatest pressure is P. So let's think about the greatest pressure first of all. So P is the greatest pressure. And how do we work out pressure? It is force over area. And we know that the force is always 105. Now, if we want to make this as big as possible, when you're dividing, if you want to make it as big as possible, the denominator, the bottom number, has got to be as small as possible. So the area of the box has got to be as small as possible. So how are we going to go and put this box on a table to make the area as small as possible? Well, you're going to pick the 2 smallest sides to be touching the table, which will be the 4 and the 3. So our greatest pressure is going to be 105 divided by 4 times 3, which is 12. So 105 divided by 12, which is 8.75. Now, our Q is the least pressure. Okay, pressure is still force over area. The force is still 105. But to make Q as small as possible. We want the area to be as big as possible. Now the biggest area is when we've got 5 and 4 touching the table. So 20. So we want to do 105 divided by 20, which is 5.25. So to answer the question, we've got to work out P take away Q. So that's going to be 8.75 take away 5.25. So 8.75 take away 5.25 is 3.5. Now, do we have to put the units down? The greatest pressure is P. Yes, I'm not sure about whether the units was included or not. I might have cut it off. So just put in the units just to be on the safe side, newtons per meter squared. I'm just going to have a quick look at the mark scheme and see if we needed to put down the units. So 3.5. No, you didn't have to put the units down. Okay, so 3.5 is the correct answer. We didn't need to go and put the units down.